Okay, we're moving on here, guys, to this in this unit, going into this factoring. He's still working with quadratics, so we're still in chapter 5. So factoring greatest common factor. So let's just do a quick example of greatest common factor. Say 4x squared and actually let's say 8x squared and 12x to the fifth. Okay, greatest common factor. It's the biggest thing they both kind of have in them as a factor, or that you could divide by. So you could divide 8 and 12 both by 4 is the biggest factor of those. And you actually could divide these both by x squared. You basically just take the bigger one out of x squared and x to the fifth. So this is the greatest common factor because I could divide this by 4x squared and I could also divide this by 4x squared and it would divide out evenly. Okay, so how does that apply here? We're just going to say, we've got a function, f of x equals 2x squared minus 6x, and the directions will say factor the greatest common factor. So we got to look at these two terms and decide what the greatest common factor is. So what number can go into 2 and 6? Well, that's 2. And then what can go into x squared and x? Well, you take the smaller one out of the 2, so you just do x. So 2x. Then you're going to say what's left after you do that. After you divide this by 2x, in other words, you're left with an x. After you divide this term, or this term here by 2x, you're left with the 3. Okay, so that is the factored form of that. If you would distribute back in like this, you'd get what? 2x squared, and you'd get minus 6x. So you're just basically undistributing, you could say. You're pulling something out. Okay, think about making a table of this now. This is kind of the point. Is like, well, how does this help me? Well, it actually helps me because I know now if I plug in a 3, I'm actually going to get out a root, right? If I plug in a 3, I'm going to get out 0 because I would have 6 here, right? Times 0, which would be 0 if I just plugged in 3. The other thing I could actually plug in now is actually 0. If I plugged in a 0, if you think about that, 2 times 0 would be 0. 0 minus 3 is negative 3. That would also come out to 0. So this is actually a way of me seeing the roots. I can see there will now be a root at 0 and there'll be a root at 3. That's kind of the purpose of factoring, or how it's helpful, is it helps us graph it, helps us find the roots like that. So here's one more. G of x equals negative 9x squared plus 5x. Look at your two terms and decide what is the greatest common factor. Between 9 and 15, the greatest factor is 3, right? You could say negative 3 because of that being negative, but you don't really need to. You can just do 3. And then again, between x squared and x, the biggest thing is an x. Okay, after I pull that out, what's left? This will be negative 3x. This will be, what, 5? This is a little trickier because it didn't come out real nice, but I can still get the roots from this actually. This will mean there's a root at 0 because if I plug in 0, it's going to be 3 times 0 is 0, and then 0 times this I think will be 5. The other root's kind of tricky, but I can say, well, what do I plug in to make this 0? What could I plug in to make this 0? So you could actually solve this out. You don't have to do this like on the delta math, but we will eventually be doing this. If I solve that out, I would actually get 5/3. So I know if I plug in 5/3, I get out a 0. So this still gives me a clue about where the roots are after you factor it, where I couldn't see those from here. You didn't really know what the roots were just by looking at this, but I can get the roots now from this. Okay, do this one on your own. Just add it to the bottom of your notes. K of x equals 12x squared minus 8x. I think that would come out pretty nice. Actually, let me switch that. Let's say 8x squared minus 12x. That will come out nicer, I believe. Okay. I'll just do it for you actually, since that one probably comes out a little weird. You guys can just add it, but if you want to try to do it on your own, you could. Add this one on there. Do one more. 8x squared minus 12x.
Okay, and that's all you got to do in the delta math, actually. So I think you're good if you got that. We'll leave it at that. Okay, so there's no assignment here, but you do need to do that delta math that's related to this, and have that done today too.